Do you want to take this event live? Okay, we're live. So, hi, Gabi.
Hi, thank you for having me.
Yeah, welcome, and thank you so much for doing the live stream with me. Everyone watching, Gabi is a geoscientist, and she's currently doing her PhD, her fourth year of her PhD. At MIT. So it's really exciting. I'm really excited to talk everything about you, about the PhD, about how you decided to do all of that. But before we get started, I just wanted to tell everyone that this live stream is sponsored by Dev Mountain. I heard your my feedback in your on your side. It's okay. This live stream is sponsored by Dev Mountain. So if anyone's interested, they can go into the description below. They're a coding boot camp and they offer web development and iOS development. So if you're looking for something on the side, a side hustle, or if you want to learn to code, you can go check that out there. So thank you to Dev Mountain. So Gabi, so geoscience. I have so many questions
Yes.
about geoscience. I know we talked a little bit before we got started, but to me, geoscience just seems like such a broad field, like ridiculously broad. Is there any way you can explain what it is in sort of like a contained, I guess?
Cohesive
Yeah,
way.
exactly. Thank you.
I think that it depends a little bit on who you talk to. Everyone might have their own kind of definition of geoscience because you can't even constrain it to just the Earth because there are geoscientists who study other planets. So it's
Okay.
not like I can even say, maybe they would call themselves planetary scientists more than a geoscientist, but there are people who kind of dabble in both the Earth and Mars or the Earth and other planetary bodies like Titan.
Okay.
So you can't even really constrain it to just the Earth. But I guess you can say that it's the study of how planets, including everything on the surface and in the core, how it all works.
Okay. So pretty much everything.
But but it's not alive generally, right? Except if you're doing like geobiology. So
Okay.
how the physical parts of a planet function.
Okay. So when you first went into your bachelor's, did
Hmm.
you know what geoscience was? Or like, did you understand this whole definition that it's sort of the study of planetary bodies and everything inside? Or were you just inside geography and you kind of just made your way through?
I was actually thinking I was going to be a chemistry major. So I was really
Okay.
interested in chemistry and in kind of like the physical sciences, I guess. But I knew I didn't want to do biology, and I didn't think I wanted to be like a medical doctor. So I had sort of sort of put that aside, and I was way more interested in doing chemistry. And I thought maybe I would end up doing like drug development or something along those lines. But when I first took an oceanography class, I realized that geoscience and oceanography, earth science, takes physics and chemistry and biology, basically any kind of discipline that you can think of in the sciences, and puts it all together and applies it. And I really liked that. So I really liked the idea of studying the natural world that, at least in my case, you can see really clearly. Some people study the core of the earth, which you obviously can't see, but at least in my case, you can see and feel and sometimes even smell what I'm studying, and I really like that.
Yeah, that's really cool. So you're in your bachelor's then. You are first a chemistry major or undeclared?
I was undeclared.
Okay, and
So
you thought you wanted
I
to be
was,
a chemistry major,
yeah,
and you took an oceanography course,
yes,
and then
exactly.
that's how you decided you had this sort of, I guess you could say it's a connection because you said like what you
Yeah,
study, yeah, it's like you can see it, you can smell it, you can touch it. And so is that sort of what sparked your interest in it?
yeah, and also thinking of the earth as a full system. So,
Yeah.
especially the way I was taught in my bachelor's, it was earth and oceanographic science is my degree. So, it's not just rocks, it's also the ocean, it's the atmosphere, it's how everything connects. And so, I really like thinking of the earth as a full system like that.
Okay. So then my question for you is how did you go from your oceanography course to then studying past climate change in cave rocks. Was that sort of just the project that you were given as your PhD, or did you sort of know that you wanted to work on this project as you went through your bachelor's?
That's a good question. I kind of ended up in cave science and well, mostly the cave stuff was sort of by accident. So
Okay.
my initial research experience was in corals, and I was using corals from the deep sea to study past ocean changes. So just like when we want to learn about history, we read through logbooks or long like journals and things like that. Because we don't have that for the ocean, we look at these corals kind of as the logbooks for past climate, past chemical conditions, stuff like that.
Oh, interesting.
So that's what I started with doing. And I thought I wanted to continue with corals because coral's so cool. Who wouldn't want to continue working with corals? But then when I met my advisor here at MIT, or my potential advisor here, and I heard about the projects he was working on, which were all about past climate using stalagmites, which are the cave rocks.
Are they the ones from the bottom or from the top?
From the bottom.
Okay.
So, yeah, the ones that grow, start down here and grow taller.
Okay.
I have a couple actually, so right here.
Oh, wow.
I keep it here all the time. This wasn't just a prop for the live stream.
Okay, so
this is where it starts.
So the
here.
layers represent something, years or?
Yeah, it depends a little bit on the sample, but for this one at least, we think that the layers are individual years.
Okay.
And then some of the like darker tan ones, I don't know how good the focus is going to be, but some of the darker ones are from where mud came into the cave during a rainstorm, for example, and it deposited on top of the nice calcite, which is this type of rock here.
Okay.
So I studied these guys.
How long is that one approximated, or how old is it approximated to be?
This one is from a cave where they grow really fast. So I would guess it's not more than 500 years old in terms of the span during which it was growing. But for this one, we don't actually know the beginning and the end date. So it could have started 3,000, 5,000 years ago, or even like 30,000 years ago, but it didn't grow for very long, if that makes sense.
Okay. Now I'm curious to why.
But why didn't it grow for very long? Or how do we not know?
Well, why? Okay, so now we're doing like a lesson. I love this.
Now we're doing, quick props here. So this is another one that we dated to be, I'm not going to remember. I don't remember off the top of my head. But this is another one that we dated, and hopefully you can see kind of this like drill mark here.
Yeah, yeah.
And so that's a place where we sampled it for uranium and thorium concentrations.
And then it grew after that?
It grew this is a different one. So it grew down here and it grew layer by layer. So this was sort of taking a sample of the beginning when it first started growing. And this is taking a sample toward the end.
Okay.
This is what it looks like on the outside.
Okay.
So we slice it in half and then we drill it. And this one, we haven't sliced it and drilled it yet. So that's we sliced it. We haven't drilled it.
Okay.
So that's why I don't know exactly how old it is. And then this one, we do have the dates for here and here, but I just don't remember them.
Okay, so moving back, no, it's good, but just like now we're going really specific. We'll have time for that. Yeah, so going back then, I want to talk still about your bachelor, because so you were doing coral reefs, you were studying their, I guess, aging and their past, to study the past ocean. And was that as a research project or was that in a course?
That was first as a research project. And then I ended up taking classes that kind of touched on it, but mostly as a research project. And the main reason that I chose that project, or that I applied to be part of that project, was because I really liked the advisor, the professor who was running it. And then there was also the opportunity to go to California, and I was going to school in Maine at the time.
Okay.
So it was freezing cold, it was dark. I love Maine, don't get me wrong, but I was like, a trip to California would be pretty cool.
Yeah,
so
I can see that.
Part of how I chose to do the project at first. So I got lucky that I really ended up liking it. But at first I was like, that sounds like fun. And I didn't really know what I was getting into.
Yeah. I'm also, because I'm also from I guess you're like way farther east than me, or not so much way far. Yeah. But I'm originally from Ontario, and now I always thought going to California would be something pretty cool, but now I'm listening to this podcast. I don't know if you've heard of it, My Favorite Murder. And every serial killer is from California. So I'm like, I think I'm just going to avoid that state entirely. So, but I'm glad it sparked your interest, at least.
Yeah, it went well.
But now you're back on the East Coast, so you're safe.
Yes, exactly.
Okay. Good. Okay, so then my next question for you is, why is it that you decided to go straight into a PhD? You told me earlier that you only took 2 months off between your bachelor's and your PhD. And why did you decide to go straight into research after doing a 4-year bachelor, right?
Yeah, 4-year, yeah.
Yeah, so I mean, I feel like most people take off, a year or at least try an internship. Were you just so in love with studying this that you were just like, nope, got to get back out there?
I was just so dorky that I was like, I have to stay in school. No.
Yeah.
I mostly chose to continue because I didn't want to lose the momentum that I felt like I had. So as a senior, I was doing a research project. I was doing my final honors thesis. We write like a bachelor's thesis in my program. And I was doing that and I was like, you know what? I'm really enjoying research. I feel like I could work on both this and do my grad school applications and write fellowship applications, which looking back was not probably the best way to do it.
It seems like a lot.
It was wild trying to do 4 classes and apply and get in touch with professors and all that. It was not maybe my best choice. So I actually would not recommend going straight into a PhD program. I made it work, but it was stressful at the time for sure. I mean, it's never going to be easy to apply to PhD programs or to any graduate program, but I don't recommend doing it the same year as you're trying to finish up a thesis as an undergrad.
If you were going to do it again, would you have taken more time off and sort of done all of the logistics in your time off? Or would you have done something like an internship or more research projects or something?
I think I would have tried to work in kind of like the environmental space. So it would have been something still science related, but maybe at a nonprofit or doing some kind of lab work possibly. So kind of science or research adjacent, but then applying that fall instead of doing it while I was also still an undergraduate.
Okay. So you said that you didn't want to lose your momentum before you applied, but I'm assuming that means you already knew you wanted to do a PhD, right?
Yeah.
So how did you know? Is it because you want to go into academia? Is it because, again, you really enjoy research and you just wanted to continue doing research? How did you know you wanted to do it?
My initial motivation was that I did want to be in academia, so I wanted to be a professor. I really looked up to my professors, and I still really do. And I thought that I wanted to provide the same kind of experience that they had given me. So I want to teach people all about how cool the Earth is and how much there is to really still learn about the Earth and planetary bodies outside of it, of course. But now that I've been doing research for a little bit longer, and I've finished 3 years of my PhD program, I'm actually leaning more toward doing communication and being more of like the full-time SciComm path.
So SciComm is science communication for anyone watching or listening to the stream. Yeah.
I'm currently leaning more toward that than being in academia. But I think that my PhD is still going to be really relevant because it gives me subject matter expertise and the ability to research a lot of things. So it means that I can take a new topic and learn about it independently. And I think that that's a really valuable tool, even if I don't necessarily need a PhD for the kinds of jobs I'll be applying for. I think it'll still be helpful, if that makes sense.
Yeah, no, that makes sense. So then maybe, I don't know if you're thinking about like the future already. I definitely kind of don't. But so you said that now you're sort of leaning away from academia. Do you already know if you want to go do a postdoc, or if you have some sort of, like if you're going to be really buckling down on SciComm opportunities, or are you hoping for just like sort of continuing what you're doing now and do a little bit of both?
For the next 2 years at least of my PhD, so finishing up, I'm going to try to do a little bit of both. So keep doing my research and keep writing and doing other communication stuff on the side. I'm considering trying to get an internship next summer, so taking the summer off of research entirely and doing an internship at a communication-focused place. So whether that's like a media nonprofit or more of like a media company, I'm not sure which yet. But I think that before I commit myself 100% and like not even apply to academic postdocs, I need to have the full-time experience to really understand and make sure that that's what I want to do.
Yeah.
Because it's a little scary to say like, all right, I'm just not going to apply for academic postdocs and I'm going to apply for jobs in the communication industry and in the education space instead. It's really scary, actually. So
yeah,
I want to make sure that I'm making the right decision.
Yeah. And no, I mean, for sure, that's why we have entire like education degrees, and you can't just hire any student to be an elementary school or a high school teacher or whatever. So yeah, for sure. I can just imagine that would be really intimidating to just show up somewhere and be like, I'm going to do all of your science communication because I'm a scientist.
Yeah. Right. And there are people who go to journalism school. There are people who have so much more experience with writing than I do. And I know that. And I really value that, and I try not to be like intimidated by it, but I definitely am.
Yeah, no, me too. I'm really bad at writing, at spelling is my worst one. No, spelling is really my worst one. If it weren't for autocorrect, it would be really bad.
Okay, I think we all struggle with that. But now, I mean, that's okay, right? Like, no one can tell as long as you proofread your stuff.
Exactly. So I think it's actually a really interesting topic to talk about opportunities for PhD students after the PhD. So, because I think a lot of students think, well, I mean, this is what I was told by my professors during my bachelor's degree. They said, if you don't want to be a professor, don't do a PhD. They said it's that simple. And, you know, for me, I want to do a PhD just because I enjoy research. I might just be a postdoc forever. Like, I don't...
Yeah, be like a research scientist. Yeah.
Yeah, exactly. I want to do research. I want to do science. I mean, I consider myself a scientist. But for me, I've only really heard after this past year about SciComm and then being in academia, like a professor. Are there any other streams that you're aware of now that you're approaching your... the end of your... you're relatively close.
Yeah, I am getting close, though. Some of the other ones that I've seen friends go into are industry jobs. So that could be a little bit in like the oil and gas industry, though at least in the U.S. right now, those firms aren't hiring quite as much as they used to be. But the oil and gas industry is one. I know someone who went and worked for a glass company, so she knows a lot about minerals, and so she took that experience and now works for like a glass artisanal company. So,
artisanal, so like glass blowing.
I don't know if they blow the glass or if they just like manufacture it.
Okay.
I'll have to look into what she's doing.
That's cool.
I think they probably do some glass blowing at least, but yeah, it's like they make beautiful art. It's not like... it's not industrial like glassware. It's nice things you'd put in your house.
Okay.
It's really cool. And then the other one that interests me a little bit too is kind of environmental consulting. So that type of thing happens. Again, this is my like U.S. perspective, but a lot of the time when they're building a new building or starting a huge construction project, they'll have to do an environmental impact assessment and say if there's like a vernal pool or some kind of stream that they would be potentially damaging, they have to figure out exactly how much damage it would do and whether it's still permissible to to do the work that they're hoping to do. So there's environmental consultants who help to analyze the data from surveys in the area and from satellite imagery, all that sort of, there's different areas of specialty, but people who work on the industry side, but really using their scientific expertise to do more research, but in a kind of a data gathering, data analysis way than in like a lab or bench type work.
Okay. So a lot of opportunities.
Yeah, I think there are so many options. And I have recently kind of gotten out of the habit of calling them like alternative career paths. So like a lot of the times they'll say either you're going into academia or you can go to an alternative career. But really, I think we should just think of them all as potential options. And academia is one great option for a lot of people, but there's also so many paths even within academia. Like you said, like you could be a postdoc forever. You could be a research scientist and not teach, and that you would probably still be in academia, but it's sort of just a different way of looking at it. So I think there's so many paths people can take with a PhD.
Yeah. Personally, I don't really know, I guess, until I'll start, but I don't think I would ever be a professor because I don't want to deal with is this the right word? Bureaucracy or yeah, like I don't want to deal with the money, getting grants, all of that stuff.
Yeah.
Like reading over papers like of students and blah blah blah. I would just like to do science. Yeah. And the occasional live stream.
Yeah, exactly.
Yeah. So someone actually asked a really good question in the stream. It's Vivek. He asked, "Can you suggest any short-term courses on climate change that he can do?" Yeah,
definitely. You can find a lot on edX, EDX, and some YouTube videos as well. But the ones I'm more familiar with are on edX, and those are university courses that are free to take online for anyone in the world. So there's other ones too, like Coursera. There's a couple different platforms, but I can put the link up, I guess, after in the comments.
Yeah, for sure. Or you can send it to me and I can put it in the description.
Sweet. So I'll send it to you, and there'll be some, like, they're called MOOCs, so massive open online courses.
Okay, yeah, you're going to need to send it to me.
Yeah. But there are courses where university professors are teaching a class, and then there's also work you can do that is like associated with it. And then you can get a certificate. You can pay to have like an official certificate that says you did it, but I don't think that's really necessary. You can just take the class and gain a ton of knowledge on your own.
Okay. And then, so personally, I am sort of looking for another course to take this semester, even though I finished all of my courses in school. I'm currently doing an internship and then I graduate. I'm really actually missing school, which is kind of right. So yeah, I'm thinking, what should I take? I could take another mechanical engineering course, but I'm already getting I feel like my brain is just full of everything that I'm already learning, already in in the discipline I'm working in. So I thought, maybe I could take like a wine tasting course, or maybe I could take an environmental course. So would you have any suggestions for someone, I guess just like you mentioned the online courses, but is there a course at university that you would suggest? Firstly, I want to hear your favorite course, and I also want to hear what course you think everyone should take. And then I want to hear another course that you think I would like. Okay.
Okay. The first one, my favorite course that I ever took, that's a hard one. There's been so many good ones. I think that my undergrad favorite course was probably marine biogeochemistry. Quite a mouthful.
Everyone that's sort of like has work related to the environment, I always tell them, like, if I could handle blood, I would have become a marine biologist.
Oh, yeah, hang out with the dolphins.
Yeah.
Fish, yeah.
Okay, so marine biochemistry?
Biogeochemistry.
Biogeochemistry. Okay.
So it's looking at the chemical processes that occur like in marshes where there's water, and then there's also places where there's no oxygen because it's always submerged in water. And there's some really, really interesting biogeochemical cycles that happen. So I really liked that class because I had already taken Intro to Oceanography, and I had taken some chemistry classes, and I felt like it really brought it all together for me in a way that was interesting, but still kind of like pushed my knowledge forward. So it was challenging. It was really hard, but it also pushed me to be a better scientist, I think.
Okay.
So that was my favorite. The thing is with geology that it really depends on your department, like your university's faculty, on what courses they offer. So it's not like, I guess in a math department, you could always have linear algebra. Like every math department is going to teach a linear algebra class. And for geoscience, it's a little bit different, where they probably will all have some form of intro level classes, and then there's just a huge variety of other classes. So there's like structural geology, there's mineralogy, where you're doing all kinds of like microscope work and figuring out what mineral is it that you're looking at. But I think the types of classes that they'll have at most places will be like an intro to geology class, and I would highly recommend that anyone take that. I think they're often you get to go outside and kind of see the local area, or you at least get to do a lot of looking at pretty pictures. So Intro to Geology, I think, is really cool. That just teaches you about rocks in general, how they're formed, where different rocks come from, stuff like that.
Yeah, so I know, like, sidebar, I feel like I'm butting in a lot.
No, it's good. It's good to have it be two-way.
Yeah, so I remember watching, have you seen Dante's Peak? It's about the volcanic eruption of Mount St. Helen, I think, in 93.
Cool.
And the protagonist of the movie was this geologist, and he was like, it's going to erupt, it's going to erupt. And everyone that didn't listen to him died, and everyone that listened to him survived. And I thought that's the coolest class, or that's the coolest discipline ever. And then
it's a lot of pressure, though.
Yeah, I guess. Yeah, that too. But then I was told when I was like, oh, I want to be a geologist, I was made fun of by like my mom, like, you want to study rocks? I'm like, really?
Yeah, I had a rock collection. Yeah, I was always that kid. Yeah. I have them still now. Like, that's why I can just pull down and be like, oh, here's the stalagmite. Like, here's a piece of coral. I just have them all on my desk here. So it's like I've just expanded my rock collection.
Yeah, so. I actually did also from different places that I've been, but now that I live in Switzerland, I couldn't just carry a bunch of rocks in a suitcase.
Yeah. Well, there's great rocks there with the Alps. And
yeah, there are. It's crazy. The rock, I mean, now that we're talking about rocks, it's actually really interesting because I go kayaking a lot.
Oh, yeah, right.
Yeah, and so this is, I don't know if like maybe okay, actually you study rocks, so it'll make sense, I guess. But in North America, our rocks are so much older. So I find that the rivers are a lot safer because there aren't these things called undercuts and sieves. So sieves is like where the rocks have been eroded by the water and stuff like that. And so the water pumps through, but a person wouldn't if they were following the flow of the water. So people die like that, or they go into undercuts like under the mountain, which is like where the water pumps through the mountain, but a person wouldn't get pumped through. And so we have a lot of those in the Alps because the rocks are younger because of, I guess, from just thousands and thousands of years of people, the Alps being destroyed and through construction and everything, and like diverting the river's pathways. And so the rocks are a lot younger here as compared to North America, which when I first heard that, I was like, but North America is young and Europe is old. Ah, okay.
Yeah. I think part of the difference also that you're seeing is that especially in Ontario where you're from, right? There's glaciers there. So a long time ago, 20,000 years ago, there were glaciers that had this soft sand underneath and maybe some big boulders, but they've had a really long time to erode and kind of like flatten out. And so everything is softer, everything is kind of more ground down, whereas the stuff in the Alps is going to be this like big, giant, like volcanic stuff. Like millions of years ago, there was a big collision that's making the Alps, right? So it was more dramatic, and it didn't necessarily have the same like big glacier sitting on it and flattening it horizontally. There's more like, because there's more topography, there's so many more mountains, the glaciers haven't had that chance to like scrape everything. So I think that's a big part of it too.
Yeah. I mean, for sure, I feel a lot safer in Canadian rivers
Yeah.
than in the Alps. But that's also because I'm not used to the rocks here.
Right. It's about what you're familiar with.
Yeah.
And, yeah.
This is really fun. I'm having like a kayaking conversation, but with someone that doesn't kayak.
Yeah.
Yeah. Most of the time, my friends are like, I don't care.
No, it's super interesting. I mean, I went whitewater rafting once, but I'm not like an extreme kayaker or anything like that.
Oh, where?
So,
Where did you go?
in Colorado.
Okay.
I was doing a research experience there, and for a weekend trip, we went rafting.
Oh, nice.
I loved it. It was really fun.
I used to be a raft guide on the Ottawa River.
Cool.
But yeah, done with that now.
Yeah. But all your kayaking adventures must be a nice break from research and being like hunched over your computer all the time.
No, they really are. Right now, it's just it's really dry in the Alps, so there isn't a lot of water. So I haven't really been in the last few, like in the last month, but I did just come back from Milan, and I went to San Sebastian surfing the weekend before, so I can't really complain.
Okay, all right. You're like, yeah, just Milan. You know,
Yeah,
like,
you know.
last weekend I went to Maine. You're going to Milan. Like,
Yeah, similar.
pretty
Both
much.
start with an M. I think yours was a little farther, though. Your travel.
Yeah, well, it's cool that you're so close to everything while you're in Europe.
Yeah, I really love it. So I wanted to know additionally, what is the coolest thing about geoscience? That, like, it could be something really cool, like you said earlier, like how everything fits together, or it can be something new that you read in the news recently, or some really cool article that you read about.
I think, oh boy, this is going to be a hard one. Okay, so there's so many. I'm thinking of, it's not like I can't think of anything. I'm thinking of so many things that are really cool. I think that depending on where you're standing on the earth, first of all, there's always rock beneath you, right? Like, even if you're in a boat, like if you go far enough down, there's rock. So I think that's cool that, like, no matter where you are, you're surrounded by geology. And for some places, that means that you're standing on rock or land that is 40 million years old. And then in other places, like in southern coastal Louisiana in the U.S., you're standing on land that has only been above the water for 1,000 years because the Mississippi River just kind of blurted it out there and moved all the sand and stuff elsewhere. And so now there's land where there didn't used to be. So just the huge difference in time scales that you can look at, like 1 billion years ago, what was here on Earth. I have some friends who study like really long time scale stuff, 500,000 years to 500 million years. Like you can just look at such a different range, whereas I study climate just over the past 2,000 years.
Okay.
So if I'm going to summarize that, I guess it would be that A, you're always surrounded by rocks, even if you don't necessarily know it. And B, that because the Earth has been here for 4 billion-ish years, there's a huge variety of how old things are. I think that's really cool.
Okay, yeah, that is really cool to think about it
Is that
that
good?
way.
Okay.
No, yeah, it is. And so you mentioned you've been you're studying rocks from only 2,000 years ago to the present. So
Yeah,
can
about
you talk a little bit more about your research and how exactly caves come into past climate change?
Yeah, definitely. So I'll get my props out again.
Okay.
It helps me remember what I'm talking about. So I study the past climate mostly in terms of precipitation. So how wet or dry was it in the past? And I'm trying to find out whether there are similar cycles in the past as there are now, because we need to understand those past cycles to better predict what's happening in the future.
Okay.
So hopefully everyone watching the live stream is aware that there is currently climate change happening on the earth, right? Like we kind of have that down. Climate is changing, but it has also been changing for millions of years. It's just about right now we're going as faster up into higher temperatures and higher CO2. The rate is much faster than we're used to, basically, than the Earth is used to.
Okay, so just to cut you off. So
Yeah,
is it
yeah,
sort of like, so people can't make the argument, I guess, not anyone in the stream, I'm just saying in general. Is it so sort of people wouldn't be able to make the argument, oh, climate's always been changing, because then you can go, no, 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 no. It's always been changing like this, and now it's changing like this or something.
Just it's
To like
the
remove the
main
trend? Is that
the
or
the justification that I like to give is that we have to understand what drives the climate. So not just what is happening, but why is it happening? So like if it's dry, what makes it dry in a certain area?
okay.
And how does warming up the earth change that kind of factor? So if it's dry because of a certain wind that's coming at it, if we heat up the whole earth, is that wind going to be stronger and is everything going to be drier? So kind of understanding the connections between things helps us to better prepare for the future.
Okay.
Is that kind of
yeah, no,
clear?
that motivation, that makes sense. And then I originally had cut you off with that question.
No,
so
that's
we were
totally
talking about we were talking like about we were talking about your research, but I'm trying to pinpoint where I cut you off.
So what's stalagmites?
Yeah.
So,
Sorry.
why the caves? So I'm studying climate in northern Mexico, and these ones are actually from the Yucatan in southern Mexico. But these are what I'm not currently working on, so I have them here as like just my rock friends to hang out with. But the way we use these stalagmites is as logbooks of past changes. So each layer, this one shows it better. These layers here are from different time periods in its growth. So if this is, let's say, just hypothetically, let's say this is 1,000 years ago, and then this is 1,200 years ago. No, sorry, 1,000 years ago.
900.
800 years ago,
yeah.
this direction. Sorry. It's confusing when you go from like BC, CE, that stuff to like before present. So that's what confused me. But because we have this sort of trapped calcite, this rock from those different time periods, we can look at the chemical composition and actually estimate how wet or dry it was in the area above the cave. So this is sort of like the best record we have of how wet or dry, how much drought there was, for example, in an area during a time when we don't have written records or instrumental records.
Okay. No, that makes sense. So basically, if you take the stalagmite...
Yeah, stalagmite.
If you take the stalagmite and you look at the chemical compositions, you see how wet or dry it is.
Yeah,
and then
exactly.
Based on how wet and dry it is, you can sort of predict the trend of... so that's in the past how wet and dry it is, and from how wet and dry it is, you predict the change of like climate change. Where's the connection there?
So my like final product is generally going to be a record of the past couple thousand years, past time, a specific time period, and it'll be that kind of like how wet or dry was it? What was the temperature doing? It'll be an estimate of those types of a quantitative estimate of those types of questions. And then hopefully by the end of that like paper, the end of that report, I will have been able to explain, and the reason I think that was happening based on this data is whatever. So it's because the ocean was warming up, and at that point that made it drier, for example.
Okay.
So that's sort of like the end of my portion of the research. And then people will take that data that I've generated, the findings that I've made,
In that
and that,
specific area
yep,
and that time
exactly.
period.
And then say, okay, so if this is kind of the direction that the climate moves, like if we turn up the ocean temperature knob, that creates this effect. At least it did in the past. So then that's how they predict using computer models how things will happen in the future.
Okay, yeah. So, in case, so whoever's watching, so it could be clear, basically, your work is, so I guess it's field work and it's being used to inform models or sort of, I guess, validate past models. Okay, that's really cool.
Yeah, so it can be used for that. Yeah. And also just to understand, like, I think it's just important to know our history, right? Because this is an area where I'm working in Northeast Mexico. People have been living there for thousands and thousands of years. So I think it's just really interesting to consider the human environmental connections and how changing environments might have impacted people living there in the past, that we don't necessarily have data on the climate part of that yet. So
Okay.
I think that's really interesting too. Even if it didn't go into the models, I would still be really interested in it.
No, I mean, I think it is really interesting. And I mean, so in the future, I know we talked about the future a lot. If you were to continue, research, whether it be in academia or wherever in industry, do you think you would want to continue researching past climate change in caves? Or would you want to still study rocks, but in a different sort of application? Or would you still want to continue studying past climate change, but maybe in a different, not
Yeah.
corals, not rocks, but maybe, I don't know, trees, old trees?
Yeah, people do that. I think in an ideal world, I would love to keep studying these human environmental connections. And so the one way to do that is like archaeology. So looking at actual human artifacts. I think I like the more natural records better. So that could be stalagmites, it could be trees. I'm kind of open to it. I kind of like the idea of applying a lot of different methods to the question of like, how did people live in terms of their access to water, and how did they handle droughts? Those types of questions we still don't always know the answer to. So I'm really interested in that kind of stuff, both just out of curiosity, but because I think we can also learn from that, and how people responded to past climate changes.
Yeah, that's really interesting to me too. When you figure it out, you just let me know. And
Okay,
then,
yeah,
okay.
I'll give you a call. Be like, all right, this is what you need to do. You need to start building wells right now.
Oh, okay. So, in like to end off the interview, I wanted to know what is your best advice for someone that wanted to study geoscience, or maybe another way to frame this question would be someone that wanted to do some sort of environmental research that would impact like the world.
I would say that if you are interested at all in kind of like outdoor research, or sorry, in terms of environmental research, sometimes people are really put off by the idea that you have to do field work and you have to be someone who loves camping and who loves like getting really dirty and gross in the mud and stuff like that. And I hear that kind of a lot from people actually. And you don't have to have that. So there's so many different ways to be a geoscientist. You can be someone who works in a lab, like a chemistry lab. You can be someone who works on computers all the time. And you can be someone who does go out and get really muddy, goes into caves and gets stalagmites. Like you can be any of those, and you can kind of be all of them also. You can, so I do all of that. Like I do stuff on the computer, I do computer stuff, and then I do spend some time in the caves. And I like the combination of it, but you can kind of find a path within geoscience that fits your interests. And so even if you're not somebody who wants to go out and hike mountains and kayak through sieves or things like you're doing, like that's okay. You can still be a geoscientist, and you can still make a really interesting impact on the environmental research that we have. So that would be one thing. I don't know if that really answers what you
Yeah,
asked.
or I
Like,
guess even if you really wanted to sleep in caves, you could also find
you
a
can do that, right? That is an
opportunity.
option. Yeah, I've never had to sleep in one, thankfully. I don't know if I could.
No, I couldn't.
I'm not as super outdoorsy as some other geologists are that I know. I kind of tolerate it, but I'm like, I would not go camping for more than a couple days. I'm sort
Okay.
of like, it's not for me. I would rather use a real toilet personally.
Yeah, I understand that. Well, if you are ever around Slovenia, around the Postojna caves, or I went to visit them last year, and the other ones too. The something with an S, I don't remember. It was like 2 kilometers high. There were huge caves.
That's really cool.
Yeah, you can. We can hang out in Slovenia, or you
Go
could
do
come
some
here.
caving. Awesome. Well, if you
Yeah.
come to Boston, there's some rivers here. It's more calm, but we can definitely kayak. So
Okay. Sweet.
I'll
I'll
make you be the one like doing most of it, and I'll be like the tour guide. You know, I'll be like, here's this big building. That's where the trails are. Stuff like that.
Okay, I'll send you a video after this on Instagram of like when I took my friend in a double kayak. That's what we can do.
Perfect.
Okay,
That
perfect.
sounds great.
Thank you so much, Gabi, for speaking to me and taking the time to do this interview. And everyone really appreciates it. I know for sure. And I'm sure more people will watch the playback later on. But
Thank you so much for having me.
yeah, such good, like informative answers. I think the PhD stuff really freaks people out, so I think it's really good to talk about that stuff. And I love talking about the environment, and I'm definitely going to look for some class to take this semester.
Cool. Yeah, I'll send those links to you.
So thank you so much. Thanks everyone for watching the live stream, and we'll talk to you guys soon.
Bye.